Okay, we start now. In the previous lecture, we talked about probability theory, and we solved some examples about finding the set of events, sample spaces, and also we solved some examples about finding the probability. We now have some more examples about probability. In this example, it says there are 5 red balls and 4 white balls in a box. Here we have a box. We have a box, and we have 5 red balls. We have 5 red balls. 1, 2, let's say 3, 4, 5, and 4 white balls. I'm gonna draw the white one in this color. 1, 2, 3, and 4. Okay. We have 5 red balls and 4 white balls in a box. So what's the total number of balls? It's 9. Here we have 9 balls. 4 balls are selected at random from these balls. Here, as we know that it's more than 1 ball is selected, that means we must use combination. Okay, since that's in random and we selected more than 1 ball, that means here we must use combination. It says find the probability that 2 of the selected balls will be red. That means 2 out of 5. So first we say 2 selected balls from the red ones. That means 2 out of 5. Sorry, we have 5 red balls. And also it says and 2 white balls. Okay, so 2 out of 4. It says find the probability of taking 2 red balls and 2 white balls. Here we take 2 from 5 and 2 from 4 also. And the total choose balls is 4. We take these 4 balls among 9 balls. Okay, here the total number of balls is 9. We take 4 balls from these 9 balls. How? 2 from the red ones and 2 from the white ones. That means we say it equals, here we take, we say taking 4 balls from 9 is the combination of 9 and 4, and taking 2 balls from 5 red ones, this combination of 5 and 2, and also taking 2 balls from the white ones, you have 4 white balls, which is the combination of 4 and 2. We have these 3 combinations. How do you write down these? We say the chosen one, the selected ones, dividing by the total one. Okay, we have combination of 5 and 2 multiplying by combination of 4 and 2 dividing by combination of 9 and 4. We just calculate this fraction. That's all. Okay, finding this is the result. Here the size of the sample space is, we take 4 from 9. We select 2 red balls. How many red balls do we have? 4. That means we take 2 from 5. Sorry, we have 5 red balls. We take 2 balls from 5 red balls. So we have the combination of 5 and 2. And we take 2 white balls among 4 white balls. So it is the combination of 4 and 2. Here we have these number of ways for selecting 2 red balls and 2 white balls. Here we say the probability is the probability of taking 2 red balls and 2 white balls from 5 red balls and 4 white balls is the combination of 5 and 2 multiplying by combination of 4 and 2 dividing by combination of 9 and 4. It equals to 10 times 6 divided by 126, which is 10 over 21. Okay, you just need to calculate each of these. For the first one is 5 factorial dividing by 2 factorial, 5 minus 2 factorial. It equals to 5 times 4 times 3 factorial dividing by 2 factorial, 3 factorial. These will cancel out. Here we have 5 minus 2 is 3 factorial. It is 5 times 4 dividing by 2. That's 20 dividing by 2 is 10. That's it. And for the second one, I mean for the combination of 1, 2 is 4 factorial dividing by 2 factorial times 2 factorial. Here we say 4 minus 2 factorial is 2 factorial. It equals to 4 times 3 times 2 factorial dividing by 2 factorial times 2 factorial. These two are cancelled out. Here we have 4 times 3 dividing 2 factorial. And 2 factorial is 2 times 1, which is 2. We get 4 times 3 is 12. Dividing by 2 is 6. Okay. And the combination of 9 and 4 equals 9 factorial dividing by 4 factorial. Then 9 minus 4 factorial, which is 5 factorial. It equals 9 times 8 times 7 times 6 times 5 factorial dividing by 4 factorial times 5 factorial. These are cancel out. As I said, we always expand the numerator to the highest factorial in the denominator. Okay. Now we have 9 times 7 times 8 times 7 times 6 dividing by 4 times 3 times 2 times 1. Okay. 4 with 8 can be cancelled out and 2 also. These 3 together are going to cancel out. And here 3 with 9, it becomes 3. 3 times 7 is 21. 21 times 6 is 126. That means it equals 10 times 6 divided by 126. It equals 10 divided by 21. Okay, this is the result. So as you see here, as it's asking about probability, as I said before, it must be between 0 and 1. And 10 over 21 is between 0 and 1. It's not greater than 1 and less than 0. So the result is 10 over 21. That is the probability of taking 4 balls such a way that 2 of them is red and 2 of them is white is 10 over 21. We have another example. It says, suppose that a dice is biased or rolled so that the number 2 through 6 are equally likely to appear. That means here the probability of appearing 2 to 6, 2, 4, 5, and 6, the probability of them is the same. That means probability of appearing 2 and 3, 4, 5, and 6. These all are the same. Here we say probability of 2 equals probability of 3 equals probability of 4 equals probability of 5, and it equals to probability of 6. But that one appears 3 times likely as any other number to appear. That means the probability of 1 is 3 times the probability of each of the others. Okay, it says 3 times of the probability of appearing the others. Here we say probability of 1 equals to 3 times probability 2 equals to 3 times probability 3 equals to 3 times probability 4 equals to 3 times probability 5, and also for 6 also. Here we say it equals 3 times probability of, let's say, 5. As it says, a probability of 1 is 3 times the probability of any other number. Okay, and also in the example, it's given that the probability of 2 to 6 are equal, means probability of 2 equals to probability of 3, and then up to probability of 6. Here, what we do, we should find the probability of each number. To find the probability of each number, we say P1 equals 3 times P5. It equals 3 times P5. And here, we say from this, as P2, P3, P4, P5, and P6 are equal, these all are equal. So you can replace any of these two others. Okay? And we say the sum of all probabilities is 1. It must be 1. The sum of all probabilities is 1. That means here in rolling a dice, we have 6 probabilities. Which is 1, 2, 3, 4, 5, and 6. So the sum of these all probabilities is 1. Here we say P1. We say P1 plus P2 plus P3 plus P4. The probability of 4 plus probability of 5 plus probability of 6 is 1. It must be 1 because we said the sum of all probabilities must be 1. And here we can replace each of the probabilities from 2 to 6 by probability of 5. We can say that. And we replace probability of 1 by 3 times probability of 5. Here these all are equal. That means probability of 6 is probability of 5. Probability of 2 is probability of 5. 4, 3, and 4, the same. We say probability of 1 is 3 times probability of 5. Is it? As we said before, it's given that probability of 1 is 3 times the probability of each of the others. We took probability of 5. So P1 is 3 times P2, is 3 times P4, is 3 times P3, is 3 times P5, and 3 times P6. Okay? We say 3 times P5. This is probability 1. This probability 1. Then plus probability 2 is the same as probability 5 because these are equal. And probability 3 is also equal to the probability 5. Probability 4 is the same as probability 5 because these all are equal. Probability 5 is itself. And probability 6 is also equal to the probability 5. These all equal 1. This equals 1. And here we say 3P5 plus P5 plus P5 plus P5 plus. Here 1, 2, 3, 4, 5, and 3 is 8. P5 equals 1. So how about the probability of 5? We say probability of 5 equals 1 over 8. This is probability of 5. How about probability of 2? It's the same. Probability of 3, 4, 5, and 6. These all are the same. That means probability from 2 to 6 is 1/8. How about probability of 1? Probability of 1 equals 3 times probability of 5, which is 3 over 8. Okay. Now, for checking, if we add all probabilities, if we find the sum of all probabilities, it must be 1. Let's check. Probability of 1 is 3 over 8. Probability of 2 is 1 over 8. Probability of 3 is 1 over 8. Probability of 4 is 1 over 8. Probability of 5 is 1 over 8. And probability of 6 is 1 over 8. It equals 8 over 8. It's 1. So that's correct. Which is correct. It's just for checking. You don't need to write down this during the exam. Only the above one is enough. Here we took P5, but here P2 is given. P2 is given. Okay. Says probability of 1 is 3 times probability of 2. May someone else take P3. It's the same. You can take any other, any probability from 2 to 6, because these all are equal. So the probability of 2 equals probability of 3 equals to probability of 4 up to probability of 6, which is 1 over 8. And probability of 1 is 3 over 8. Refer to the previous example. What's the probability to obtain an odd number? What are the odd numbers from 1 to 6? 1, 3, and 5. So the probability of odd number is the probability 1 plus probability of 3 plus probability of 5. That's either 1, 3, or 5. It's 1 or 3 or 5. That means here the probability 1 or 3 or 5 is the probability 1 plus probability 3 plus probability 5. Probability 1 is 3 over 8. Probability 3 is 1 over 8. Probability 5 is 1 over 8. It equals to 5 over 8. How about the probability of an even number? That's probability 2 plus probability 4 plus probability 6. It equals probability 2 is 1 over 8. Probability 4 is 1 over 8. Probability 6 is 1 over 8, which is 3 over 8. Okay. How about the probability of a number which is greater than 5? Only 1 over 8. We have only 6. How about the probability that a number to be odd or greater than 4? Look, for the odd ones, we have 3 over 8, which is 1. Let's write down the numbers. The odd ones are 1, 3, and 5. And numbers which is greater than 4, that's 5 and 6. But here we already have 5, so you just write down 6. That's 3 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8, which is 6 over 8. It's like that. Okay, that's all possible questions about these type of examples. We have another example. Do you have any question about the previous one? Okay, try this one by us. It says, what's the probability that if a fair coin is tossed 6 times, you'll get less than 2 heads, at least 2 heads? Okay, here we have a coin, we flip it 6 times. So what's the probability that if we get less than 2 heads? And what's the probability that if we get at least 2 heads? In flipping a coin 6 times, for each time we have 2 possible outcomes. It's either head or tail. So in flipping the coin 6 times, that means we have 2 to the power 6 possible outcomes. We have 2 to the power 6 possible outcomes. So our sample space is 2 to the power 6 members. So this is the possible outcomes. We have 64 possible outcomes. And here we are asked 2 questions. The first one, what's the probability of less than 2 heads? That means we either have 1 head or no head. In only one case we have no head. If all turns is true is tail. So we have these possible outcomes for this one. It's either all or tail, and one of them is head. So make the first flipping the coin as head and the others tail. Make the second time is head and the others is tail. Make the third time is tail, is head, sorry, and the others is head. So it's tail. And also make the fourth time. Make the fifth time. Make the last time. We have only these possible outcomes with either one head or no head. Because in the question it says less than two heads. Two heads. That means we must either have no head or one head. We have 7 possible outcomes. We have 7 possibilities for taking less than 2 heads. So the total of possible outcomes is 64. We divide this by 64 to get the probability of less than 2 heads. So the probability of less than 2 heads is 7/64. That's it. That's all. For the second part, it says at least 2 heads. Do we have any other possible outcome except these two? Less than 2 heads and at least 2 heads? We have no more possible outcomes. So in flipping the coin 6 times, it's either less than 2 heads or it's at least 2 heads. That means these two are the total outcomes. So the probability, the sum of all probabilities is 1. We say the probability of less than 2 plus probability of at least 2 is 1. You see, probability of less than 2 2 heads is, we found that, which is 7/64 plus probability of at least 2 heads equals 1. It must equal 1 because we say the sum of all probabilities must be 1. We have only these 2 possible outcomes. It's either less than 2 heads or it's at least 2 heads. It equals probability of less than 2 heads is 7/64 plus probability of at least 2 heads equals 1. How to get the probability of at least 2 heads? You say the probability of at least 2 heads equals 1 minus 7/64, which is 57/64. This is the probability of at least 2 heads. Okay, you even can find it by writing down all the sample space members, but it takes too much time here. You should write down 57 possible outcomes for 6 rolling for rolling the coins 6 times. So this way it's easy to find the probability of at least 2 heads. And also it's done there. We now have probability of a general union of 2 events. We say if you have 2 events, events A and B, where A is the sample space, then the probability of A or B equals probability A plus probability B minus probability A intersection. Change this to intersection B. Change this to intersection. That's probability A plus probability B minus probability A intersection B. If the events are not mutually exclusive, if they have common. If here we have two events, A and B, A and B, from the sample space of S. We say if A and B are not totally disconnected or are not mutually exclusive, that means if there is intersection point between these two, or if there is common between these two, we say the probability of A or B equals probability A plus probability B minus probability A intersection B. Fix this. This is intersection. Okay. Now we have an example. It says, in a math class of 30 students, we have a math class, and there are 30 students in the math class. So S here is 30. 17 are boys, 13 are girls. We have a math class. Let's say 13 girls and 17 boys. On a unit test, 4 boys and 5 girls made A grade. Among 17 boys and 13 girls, 4 boys and 5 girls got A grade in the test. If a student is chosen, look here, we just choose only one student. We don't choose more than one student, so we don't need to use combinations here. If a student is chosen at random from the class, what is the probability of choosing a girl or a student? I mean, if we choose a student, so what's the probability if that student is a girl or it's from the students who get A grade? Here we have 9 students who got A grade. We have 9 students who got A grade. Among these 9 students, 5 of them are girls. 5 of them are girls. And it says, what's the probability of choosing a girl? We have 13 girls. So you take 13 from 30. Okay, that's 13 probability of A, girl or A, is probability of girl plus probability of A. As we said before, we say probability A or B. Here we have 2 events. The events are girl or A. Girl or A. We say probability of girl plus probability of A minus probability of girl and A, with the intersection of probability of girl and those who got A grade. Probability of girl and A. So how many girls got A grade? It's given that here 5 girls got A grade. Here we have 5. And how many students got A grades among both boys and girls? It's 9. How many girls do you have in the class? 13. We divide each by 13 and we find it because we take each from 13. Here we have 30 students. Among these 30 students, 17 are boys and 13 are girls. The students take a test. In the test, 5 girls got grade A and 4 boys got grade B. 4 boys got grade A. That means you have 9 students who got grade A. Among these 9 students, 5 of them are girls. Okay, so in this question, it says, what's the probability of choosing a girl or an A student? We have 2 events. That's either girl or A student. Girl or A student. So you have these 2 events. The event of girl, the student A. So you have probability of girl or A equals. We just apply the above rule. This rule. This is girl. This is A. I mean those students who got grade A. That's probability of girl plus probability of A minus probability of girl and A. That means the intersection between those students who got A grade and the girls. We have 13 girls. Among these 13 girls, 5 of them got A grade. That means you have 5. So this is 5. How many girls do we have? 13. We take it from 30 students. We have 30 students in the class. Plus. And how many students got A grade in the class? We have boys and girls in the class. So how many students got A grade? 9. Minus. And how many girls got A grade? 5. You should find the intersection of girl and A grade. That means the number of girls who got A grade is 5 over 30. Just calculate this, you get the result. Okay? It's about the next example. Do you have any questions about that? So let's take a break for 10 minutes, okay? We have another example. It says 2 fair dice are rolled. What's the probability of getting doubles? The doubles are 1, 1, 2, 2, 3, 3, and 4, 4. In rolling a dice, we get in rolling a dice, we get 6 possibilities from 1 to 6. But in rolling 2 dice or a dice twice, we get 6 squared, which is 36 possibilities. And the doubles are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. It says, what's the probability of getting a double in rolling 2 dice? Or sum is of 6, or sum of 6. Here you have. We should find the probability of double or sum of 6. Sum of 6. Here, the probability of getting, the possibilities of getting doubles are these: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. That means probability of getting double, we say let A denote the event of getting doubles. That means probability of A equals 6 dividing by 36. Our sample space is 36 because in rolling 2 dice, we get 36 possibilities. And it says the probability of getting doubles. We have only 6 doubles in rolling 2 dice. That means it is 1/6. Let's leave it like the same. It is 6/36. Or sum of 6. Or sum of 6. Let's write down all the possibilities of getting sum of 6. So sum of 6 are 1 and 5, 5 and 1, 2 and 4, 4 and 2, and 3, 3. We have only these 5 possibilities to get the sum of 6 in rolling 2 dice. We have only these 5 possibilities. الهلداني دوبر دزارة تنها أو احتمالات تمان هي ب sample space أكد سيركين. That's it. This is the sample space of rolling 2 dice or a dice twice. It says find the probability of getting a double. Look, these are doubles. We have only these 6 doubles. Or getting the sum of 4. The sum of 4. Yeah, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 1 and 5. We have these 5 possibilities to get the sum of 6. That means here we have 5 possible outcomes to get the sum of 6, and also we have 6 possible outcomes to get a double. Let's return to the example. And the probability of B, we let B denote the event sum of 6. We let B denote the event in getting sum of 6. That means probability of B is how many possibilities do you have the sum of 6? We have 5. 1, 5, 5, 1. 2, 4, 4, 2, and 3, 3. We have 5 possible 5 possibilities to get the sum of 6. So the event of getting the sum of 6 is this one, which is 5/36. Okay, so is there any common between this one and this one? Is there any common? Look, 3, 3 is in both. So you have only one element which is common. You have one, that means the intersection of these two. Look, event A equals 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And B, the event B is 1, 5, 5, 1, 2, 4, 4, 2, and 3, 3. So what's the intersection between these two sets? The intersection of these two sets is only one element, which is 3, 3. 3, 3 is common in these two events. That means we have only one element in the intersection of these two events. And we apply this rule. We say probability of A or B equals probability of A plus probability of B minus probability of A intersection B. So what's A intersection B? A intersection B is only 3, 3. So what's the probability of 3, 3? Our sample space is 36. We have 36 elements in the sample space. That means the probability of A intersection B is 1 over 36. And we found probability of A is 6 over 36 plus probability of B is 5 over 36 minus probability of A intersection B is 1 over 36, and it equals to 11. It's 10 over 36. We can cancel out these two, get 5 over 18. You can divide both numerator and denominator by 2, we get 5 over 18. That's all. Okay? So here, if there is common between the events, we say probability of A or B equals probability A plus probability B minus probability of their intersection. The intersection of getting doubles and getting the sum of 6. We have only one intersection between them, which is 3, 3. We have only one element in their intersection, which is 3, 3. So the probability of their intersection is 1 over 36, because our sample space, in our sample space, we have 36 elements. So the probability of any case, we divide by 36. The case of getting double is 6. 6 divided by 36. Getting doubles. For getting 6, we have 5 possibilities. We divide 5 by 36. And the intersection between these two is only 3. 3, 3, I mean. The probability of 3, 3 is 1 over 36. We just find this one, which is 5 over 18. That's done here. I'm going to clean this. Do you have any question? Just apply the rule, you get the result. It's so easy. Yeah, that's A, that's B, and A intersection B equals only 3, 3. So the probability of A is 6 over 36. Probability of B equals 5 over 36. Probability of A intersection B is 1 over 36. Just put these values into the rule. The rule is probability of A or B equals probability of A plus probability of B minus probability of A intersection B. You get that. Just try to identify what's A, what's B, and what's their intersection. If there is any common between them, it's in their intersection. Here you have another example. It says, suppose that a student is selected. We just select only one student, so we don't need to apply. We don't need to use combinations at random. Among 90 students, we have 90 students. Among these 90 students, we just select one student, where 35 are over 100 pounds. 20 are boys, and 15 are over 100 pounds and boys. We have 90 students. We have 90 students. This is 90. And it says 35 are over 100 pounds. Here we have 35 over 100 pounds. We have 20 boys. We have 20 boys. Among these 20 boys, 15 of them are over 100 pounds. So here we have 15. Okay. We have 15 boys. Among all 90 students, we have only 20 boys. We have only 20 boys. Among these 20 boys, 15 of them are over 100 pounds. So we have only 5 here. We have 20 boys. Among these 20 boys, 15 of them is over 100 pounds. It says, what's the probability that the student selected is over 100 pounds or boy? Or boy. How many boys do we have? 20. How many students are over 100 pounds? 35. And how many students do we have with boy and over 100 pounds? 15. We let A to be the event, be the event. Over 100 pounds. And let B be the event boy. Okay. What's the probability of A or B? It equals to probability A plus probability B minus probability of A intersection B. Why do we apply this rule here? Because there is common between those students who's over 100 pounds and the boys. Because we have some boys, we have 15 boys which are over 100 pounds. And the number of students who are over 100 pounds is 35. And here we say probability of A or B equals probability A. What's the probability of over 100? 35 over 90. Over 90. If you see the word probability, you must divide it by the total number of the total number. Okay, here we have total number of students. The total number of students is 90, was 35 over 90. Then plus probability of boys. How many boys do you have? We have 20 boys, as it's given here. 20 are boys. We say 20 over 90 minus the common between them, the common between them. We say, what's the probability of having boy and over 100? It's given that 15 boys, you have 20 boys, and 15 are over 100 pounds. Okay, 15 of the boys, 15 of the boys is over 100 pounds. We say probability of 15, which is 15 over 90. $35 of the students, the total number of students is 90. So for any case, for finding the probability of any case, we divide by 90. Okay, 35 over 100. Among these 35, 15 of them are boys, and the number of boys is 20. To find the probability that the student selected over 100 pounds or boy, we let A to be the event of over 100 and B be the event of boy. We apply this rule here. We should find the probability of over 100 and boy and their intersection also. As you see here, their intersection is 15. It's 15. You see, probability of 35 is probability of over 100 is 35 over 90. Probability of boy, we have 20 boys. You see, 20 over 90 minus probability of their common. The common is 15 students, 15 boy students. You say 15 over 90. You just find the result of this. It is 40 over 90. Okay, so the result is that. That's the result. You can cancel out this. It becomes 20 over 45. And then it becomes 4 over 9. Yeah, it's 4 over 9. Dividing by 10 is 4. Dividing by 10 is 9, which is 4 over 9. This is the probability of a boy or a student which is over 100 pounds. Here you have 2 exercises. That's for yourselves. Now you have mutually exclusive events. If you have 2 totally different events, if we have 2 totally different events, it means if there is no intersection between the events. In this case, we just say it equals to probability A plus probability B. Probability of A or B or A union B equals probability A plus probability B. This probability A union B, even the above ones could be written like that. Look, that's A union B. That's probability A union B or OB. This probability A or B, I mean the sign, this one which I used, which I have written A or B, this means union. Okay. We say if the intersection of the events is an empty set, that means if there is no common between the events, in the previous examples, there is common between them. For example, in the rolling 2 dice, if you get double or the sum of 4 of 6, the sum of 6, as we said, as we saw that there is 3 in both events, so their intersection is not an empty set. That's why we use the above one. But here, from now, we talk about those examples, those problems which have 2 events, totally different 2 events. We say the probability of A union B or A or B equals probability A plus probability B. We don't write down probability A intersection B because he has empty set. Probability of empty set is 0. We talked about this. If there is no common between the events, we apply this rule. Here you have mutually exclusive events and non-mutually exclusive events. This is non-mutually exclusive events. As you see, for events A and B, there is intersection between them. There is common between them. If there's common between them, we apply the above rule and the previous rule. But if there is no common between events A and B, if there is no commons, that means if their intersection is an empty set, we just say the probability of A union B or A or B is probability of A plus probability of B. That's all. Here you have an example. It's about exclusive and non-exclusive mutual events. A single card is chosen at random from a standard deck of 52 playing cards. What's the probability of choosing 5 or king? A 5 or a king? There is no common between 5 and king. یه چی من هست؟ ale کارد راجشون اینا 52 کرد. probability او كارتي كرام قشاو اي احتمال شيء بينج بيت ياخذ باباز بيت باشا هیچ لنیا پاپاز و پنجا هیچ یک برینه نیه هیچ هاوشک نیه. So in this case we must apply the mutually exclusive events. In this case we must apply the probability of A union B equals probability A plus probability B. Okay, we apply this rule here because there is no common between events A and B. Event of A is choosing a 5, and event of B is choosing a king. The second experiment here, it says a single card is chosen at random from standard deck of 52 playing cards. What's the probability of choosing a club or king? This type of cards is called club. باشا على شيء احتمال شيء او كارتي كرائي شيء كوب بيت يام باباز بيت وين باباز كوب ما هي كواده خالي هذا الشيء. Okay, and here there is common with it could be the king is club, we have club king. Okay, that means there is common between them, there is common between them. In this case we apply this rule, we say probability A or B equals probability A plus probability B minus probability A intersection. Okay, in this case if there is common between the events, we have two events, either club or a king, club and king. The king could be club, that means there is common between them. In this case we apply that rule. Now you have an example. It says two feathers are rolled, find the probability of getting doubles or the sum of 5. Let's first write down the doubles and write down those which is the sum of 5. Here the doubles, we let A denote the event of getting doubles, so A equals, it's easy to write down both events. The doubles are 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. And we let B denote the event of getting the sum of 5. In rolling 2 dice, it could be 1 and 4, and also 4 and 1, 2 and 3, and also 3 and 2. We have no more options here. As you see, this is B. Is there any common between A and B? Is there any common between A and B? A is the set of doubles. B is the set of those elements with their sum is 5. There is no common between them. The intersection of these two sets is an empty set. That means what we say, we apply this rule for finding the probability. It says the probability of A or B equals probability of A plus probability of B. Probability of A is, in rolling 2 dice, how many elements do you have in the sample space? How many? 36. Yeah, we have 36 elements in the sample space. In A, we have 6 elements in A. We have 6 elements in A. Say 6 divided by 36. That's for probability of A. Plus. Probability of B is 4 over 36. That's all. It's 10 over 36. Okay. is 10 over 36, which is 5 over 18. 10 over 36, you can cancel out or divide both numerator and denominator by 2, you get 5 over 18. Is that easy? Could you do this by yourself? Here you have a glass. Let me explain it for you first. We have a glass. Which contains 1 red, 2 green, 2 blue, sorry, 3 green, 2 blue, 4 yellow marbles. ماني هالمادة عشان هالمادة marbles. دفرك معناها now دفركها أم يكسر سيسوسو دوشينو شوارزر أنا هالمادة يعني. Okay. It says if a single marble is chosen at random from the jar, what's the probability that it is yellow or green? Is there any intersection between yellow or green and green? There is no intersection. Okay, that means the probability of getting a yellow one is the number of yellow marbles divided by the total number of marbles. Here the total number is 10. Okay, it's total. You have 10 marbles in the jar. What's the probability of taking a yellow one? Probability of yellow equals 4 over 10. How about the probability of green? Just find the sum of these. Okay, so the probability of yellow or green equals 4 over 10 plus 3 over 10, which is 7 over 10. Okay, so the result is 7 over 10. Okay, so how about in the previous example, let me change and do it by yourself now. What's the find the probability of getting doubles or the sum is, let's say 4. How about this one? What's the probability of doubles or the sum is 4?
The double is the same. And for 391, 394,
It's easy. So what's the result? Here, there is common between the events. Doubles are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And the symbol 4, we have 2, 2 in it. That means there is one common, one element is common. So A intersection B is 2, 2. The probability of A intersection B is 1 over 36. Probability of doubles is 6 over 36. And probability of the sum of 4 is 3 over 36. That means it equals to, for this one, it is probability of doubles is 6 over 36 plus probability of the sum is 4 is 3 over 36 minus probability of their intersection. You have only one element in their intersection. It's 1 over 36, which is 8 over 36. Okay, and equals to 2 over 9. The result is 2 over 9. Be careful in doing it. If there is common between them, you should do this one. If not, write down the same without the probability of intersection B.